Hello, I'm back to my channel Knowledge Spread by Sir Boots. And before anything else, I would like to give shout out to my students in YUMS grade 11 in Kidapawan City National High School, YUMS Strand, Yum, from YUMS A, YUMS B, YUMS C, YUMS D, YUMS E, and YUMS F, and the entire strand of Kidapawan City National High School. In this video, I am going to give more examples on how to find the inverse of the function. And because in the first uh, part of my presentation of how to get the inverse of the function was not enough, I think, uh, for you to uh, learn more on the concepts and the skills on how to solve for the inverse of the function. Now, uh, I'll give you an example on how to find the inverse of the functions. Example, uh, find the inverse function of g of x equals x cubed minus 3. Well, we are going to rewrite that here. G of x equals x cubed minus 3. We change g of x to y equals x cubed minus 3. Change y to x and x to y minus 3. So I will use the common commutative property, changing the places of y cubed minus 3 to the left and x to the right. When you use the commutative property, you don't change the sign when you transfer, because you transfer all the terms in the right side to the left side, and all the terms in the left side to the right side. So there will be no changing of signs of the terms. Okay, to solve the function further, we have y cube is equals to x plus 3. So in order uh, read to to get the value of y, we have to get rid of the cube. So we are going to get the cube root of y cube, so that we can get the value of y. So y cube equals x plus 3. So we just extract the cube through the cube root. Extracting the cube root of y cube. Okay, I will transfer it there. This is y cube, y cube, x plus 3. This is cube root. So here we cancel the cube by the cube root. So finally we have y equals x plus 3, the cube root of x plus 3. And so that is already an inverse function. We have f negative 1 of x equals the cube root of x plus 3. So that is now the answer. The inverse of g of x equals x cubed minus 3. So another example. I'll give you another example. Find the inverse. This is number 1. Number 2. Find the inverse of f of x equals 3x minus 2 over 2x plus 5. Okay. So we change f of x to y equals 3 change x to y minus 2 over change x to y plus 5. So we multiply these terms in the denominator. We multiply that there to y. So we have y not yet. I'm sorry. We are still okay. I'm sorry. We change first y equals 3x minus 2 over 2x plus 5. Here we go. We are going to change y to x equals 3 and x to y minus 2 over 2 change x to y plus 5. This one we are going to cross multiply, or we multiply 2y plus 5 to x in the left side. So we have x times 2y plus 5 equals 3y minus 2. Then we multiply x to both 2y and 5. So x times 2y is 2xy. Then x times 5 is 5x. 5x equals 3y minus 2. So we group the terms with y in one side of the equation, that is in the left side, and all the rest in the right side. So we have 2xy. This one, by virtue of the addition property of equality, we are going to jump 3y over the equal sign to get into to transfer to other side, and we change the sign. That is negative 3y, and also positive 5x. You jump over 5x, jump over the equal sign to get to the other side, and we change the sign. That is by virtue of the addition property of equality. So we have that. And y is common in the two terms. So we bring that out. Now we bring that out, that common y. Okay, so what we are going to write in the parentheses is r 2x minus 3. Okay, equals negative 5x minus 2. So 2x minus 3 is the coefficient of y, so we divide it by 2. Okay, we bring it there. So we cannot see. Okay. Here, y times 2x minus 3 equals 5x minus 2. Okay, so y has a coefficient of 2x minus 3, so we cancel or divide 2x minus 3 to both sides of the equation. So 2x minus 3. So this is cancelled. Cancel. So what is left is y equals 5x minus 2 over 2x minus 3. Okay, and that is already the inverse of the function of 3x minus 2 over 2x plus 5. So we have the inverse function of x equals 5x minus 2 over 2x minus 3. Okay. So another example. Okay. Another example. In mathematics, there is always easy problems and difficult problems. I'll give you some example on hard problems. Example, find the inverse of of f of x equals x squared minus 2 over x if it exists. So the function is f of x equals x squared minus 2 over x. Again, we change f of x to y. Y is equals to x squared minus 2 over x. And we change y to x and x to y. Y squared minus 2 over y. Okay, so we change y to x and x to y. Then we multiply y to x in the left side. So x times y is x to y. equals y square minus 2. Okay. So, it is y square here, and it follows that it is quadratic equation. So, we're going to set this to 0. No? We have y square. Okay. We are going to have this y square minus xy minus 2 equals 0. So, y square minus xy, because we jump it over the equal sign to transfer to the side, to have a quadratic equation in the form of ax plus b, in the form of ax plus ay plus ay squared plus by plus c equals 0. So we have, we will use the commutative property, y squared minus x y minus 2 equals 0. So, how to get the value of y here is that we're going to complete the square by completing the square, because we cannot solve this by factoring. No? And it's also difficult also to have the quadratic formula, so we'll use the completing the square. To complete the square, we need to negative 2 will not make y square minus xy a perfect square. Perfect square means like x square plus 4x plus 4. If we are going, the purpose of making it a perfect square, no, is for us to get the square root. For example, this one is a perfect square because this is perfect square. We can make the square. We can get the square root by getting the square root of x square, then adapt the sign of the b. This is b, and get the square root also of 4. That is 2. The square root of x square is x. No. Then use the sign of b, and the square root of 4 is 2. So you square that. You square that, and if you are going to use the FOIL method, you multiply that, you will go back to x square plus 4x plus 4, x plus 2. So by FOIL method, this is x square, then this is 2x, then this is 2 times x is 2x, then this one is 4. So you're going to have the answer x square plus 4x plus 4, just the same. No, I am just illustrating that so that here we can put a term that will make this a perfect square. And the formula for making supplying a term here that will make this a perfect square is b square, b over 2 square. Okay, so we will first transfer negative 2 to the other side. So no, by jumping over the equal sign by virtue of the addition property of equality. We have y square minus xy equals 2. So you add a term here that will make this a perfect square. And the same term also will be added to the other side. So our b here is negative x. Our b is negative x. A is 1, b is negative x, and c is 0. So our b is negative x, and the formula is b over 2 squared. No? B over 2 squared shall be placed here to make this a perfect square. So we have our b is negative x. So we divide that by 2 because the formula is b over 2, then square it. So we have x square over 4. No, x square over 4. So here we add x square over 4. Also here x square over 4. So we add x square over 4. X square over 4. So we can now express this into square of binomial. So the square root of y square is y. So we'll go there. Adapt the sign of b. And the square root of x square over 4 is x over 2. The binomial, that is square. So in the other side, we multiply 4 to 2, that is 8, plus 8 plus x square all over 4. Now, we rewrite it here. Y minus x over 2 square is equals to 8 plus x square over 4. So we can get the square root of y minus x over 2, no, by extracting the square root. So extract the square root here also. So but this becomes plus or minus. So as we extract the square root, now the square root of this y quantity of y minus x over 2 square, we cancel the square by the square root. So we have the remaining y minus x over 2 equals plus or minus the square root of 8 plus x square over 4. Or we have y minus x over 2 equals plus or minus the square root of 8 plus x square over 2. Finally, we have here, we transfer this to the other side. So y is equals to plus or minus the square root of 8 plus x square over 2 plus x over 2. So we have, this is already the inverse function. So we have the inverse f of f negative 1 of x is equal to plus or minus the square root of 8 plus x square over 2 plus x over 2. So this is now the inverse of the function x squared minus 2 over x. Okay, I hope that you understand. You just view it repeatedly so that you will understand, especially how to develop your skill in completing the square, so that in the future you can easily complete the square if there is a need. And this is all for this video. Bye bye and thank you.